Sound design.
So what's it like to do sound for Senator Kamala Harris? That's what I want to talk about in today's video. I got a last minute gig last week and it's the first show that I've done in months, so I thought it'd be fun to dissect it a little bit. So here's what I'm going to talk about: the design, calibration, RF, mix, and recording of this event. So this was down in Edinburgh, Texas, I believe. It's right on the border, and it was in the parking lot for UT Rio Grande Valley. Here's a picture here. Here's the stage, catwalk. There's the senator. Front of house is back over here on the right behind this guy. And here's our speakers. So the idea is that this light pole should kind of hide them, and it kind of did. Like, I think if I hadn't pointed these out to you, you probably wouldn't be able to see them. I mean, they're pretty small, but it does help that they're kind of back over here on the side. Normally, we'd try to put speakers on either side of the stage, playing out this way and that way, or forward or something like that. But we needed this to look good for the live stream. That's where the largest audience was going to be. And although there are 200 people here in cars in this kind of drive-in style, that wasn't kind of the main event. So we needed this to look good. So the speakers are kind of out of the way. And originally, this was going to be for, I think, 200 people maybe sitting together, or not together, but, distanced, but in a room. And so, this would have been a little bit easier to do with these speakers. With this many people spread out, I think we were underpowered with these speakers, but we did make it work. But I'm just letting you know that another reason why I wanted to put these two arrays together, one playing out here 300 feet and the other one playing this way 200 feet, is so that they would hopefully couple a little bit in the low end and just, get me all of the optimized power that I could out of these things. And then there's some subs down here that you can't see in this picture, but you can hear in this picture. So I had never used these RCF speakers before. HD20-A, I think they're called. So here's a picture of the design software that I use, HDL20-A. And apparently there's better software, but I couldn't find it. I went to the RCF website and it said this is the software to use, so this is what I used. So if you know of a better piece of software to use for their designs, please let me know. It's pretty simple. You just put in the audience plane, height, and number of cabinets of the array, and that's it. You can hit auto display. Now, it's really important to know some things about how arrays are designed and optimized, because there are a handful of pieces of software like this where it's an auto solver, and if you hit auto display, it's going to give you a bunch of 0 degrees settings up here. And I don't think I have ever used 0 degrees in an array, and there's some hardware out there where you can't even put in 0 degrees. Like the smallest display you can use is something like 0.5 degrees. Now, this is a bit tricky in an array like this because there is no 0.5 degrees. There's only 2, 4, 6, 8, 10. It reminds me kind of the old days using DB technology speakers, and those are also pretty limited. Like, you can get up really high with display, but you can't get those small increments, which I think we as sound engineers often wish were available. Okay, so you hit auto display and it gives you it does fill the target coverage angle down here, but it's not really optimized. So I played around with these manually until I found something that I thought looked better. And then we deployed it. And I think the only thing that we actually changed in the field is that, it's kind of weird using these lifts because they can't go back as far as you need them. I run into this problem often. I forget about how to use these, and then I have to put up speakers, and I'm like, oh yeah, you can't do a deep curve here because it's going to run into the back of this thing. So I think what happened is that we raised them up, and this bottom speaker was hitting the back of this thing, and I was like, okay, that looks dumb, and it's messing up the aim, so we'll take one box off of here and put it onto here. And I think that's the only thing that's changed, and then we put both subs down here together. Okay, that's the design. Let's look at the calibration. One funny thing is that someone started up a generator right next to one of my mics in the middle of my tuning, and I had no idea. It was like far enough away that I didn't really hear it, but I saw that one of my mics disappeared, and I was like, huh, and I started playing around with it for a while, and eventually I walked over there and saw that, like, oh, now I'm measuring the sound of a generator and not my speakers. So I deployed 3 microphones as sort of like my near, mid, and far field. And let's see what those look like. Before we do that, here's the target that I often use for outside. I have a top and a bottom and just try to get everything inside those. If you want these targets, I'll put a link below this video where you can download those. So a couple of days before the event, I knew that we were getting the HDL20-As. And so I downloaded their GLL files. And if you didn't know, you can open up those GLL files in the GLL viewer and then export a table and then open that in Smaart. And then you have, an anechoic measurement of the speaker to compare to in the field, which is super helpful if you're someone like me that has never used these speakers before. You have no idea what to expect. And so I want to know, what should the magnitude trace look like without the effects of the room and the rest of the array? Okay, here's what a single box looks like. And then what should a 7-unit array look like? And now the magnitude is missing because, here we go. So I'm going to play with this until I kind of get that pink trace in some place that looks helpful. I'll hide the single box, and then I've got to remove the offsets. Okay, so this is what this should look like with 7 units. And I was doing 9 on one array and 9 on 5, but okay, at least I have some idea now, right? And now let's take a look at my first measurement, and we can see that there are some similarities, right? This is really clearly the same. This is all very similar, right? So especially up here in the upper mid-range and in the high end. Okay, so that was nice to have. So I got this out, compared this to my target. I listened, I said, okay, yeah, I think I want to attack 3 areas. And this is what I usually do, especially when I have a very small amount of time. I say, okay, let me just pick 2 or 3 areas to try and take action on and see if it makes an improvement. So I said, okay, let's put a filter here. Let's try to do something here. Let's try to do something here. And I think that's what I ended up doing. So I did all of the processing within the M32. That's all I had available to me. So you can see here on the EQ, that's exactly what I did. 550 hertz, 8K, and down here a low shelf. And I'll tell you, I fought with this low end for a bit, but I didn't spend too much time on it. I noticed that I put the low shelf in, there wasn't much of a change. I turned the low shelf way down immediately, and there still was only a little bit of a change. I listened to it, I talked into a mic, I played some test tracks. I like these 2 filters here. This one didn't seem to do much. So I ended up just reducing it, by 6 dB, and that seemed to help a little bit. And then I let the rest of it go. It didn't sound like a problem, even though it looked like a problem. So you can see the change. Got rid of that bump at 550. This is reduced a little bit around 8K. And now the main sub alignment. So here's main, here's sub. I can zoom into the low end. And yeah, so what's going on here? Well, we can see we've got a crossover region from about 550 to, let's say, maybe up to like 160. And I can see that because the main drops out pretty severely here below like 60. But then they stay together, affecting each other up here into the high end. And this is without me applying any filters. This is just native on these speakers. They do have a bunch of buttons on the back where you can change things, but I think it was all just default settings. And that's as much as I can say about it because I did not play around with those settings. I think I just tried to leave everything on default. So what I did was I said, okay, let me look at like the center of this crossover region. Let me scroll this phase trace around a little bit so it's easier to look at. And I said, okay, here is the subtrace. Here's the subtrace, and I can see that, okay, in this here, it needs to bend down. I need to add delay so I can get these to be on top of each other. I added delay. I got them to be on top of each other here in this region, but not up here. But I was kind of working quickly, and I just thought, oh, they're aligned here. That's great. And then, I turned on combined systems, and I said, okay, great. I've got summation through the crossover region. So here is combined systems, and I will move this whole graph a little bit down so it's easier to look at. But here you can see, like, I have this bump here where I'm aligned, and then if we go down here, you can see I don't have summation. And in fact, it looks like I have a little bit of cancellation in areas where I then get out of alignment. And if I turn this down a little bit, here we go. So I see now that the alignment could have been improved a little bit. This happens to me all the time where in the field, I'm trying to work quickly and it seems like that's good enough. That's great. But then later on, I realized, oh, those weren't quite the right settings. So I thought it'd be fun to take a little bit further look at this. So what you can do is you can export these to ASCII. And before you do that, it's always a good idea to turn off this coherence blinking threshold, turn off any smoothing that you have here. You see I have some smoothing in the phase trace. And then export those to ASCII. And then you can open them up in SatLive or RumiQ Wizard or some other audio analyzer that has some of these auto solvers for you. And I'm going to use RumiQ Wizard this time because a new feature in RumiQ Wizard is this thing called Alignment Tool. And this is pretty fun. So if I reset everything here, you can see that I've got this red trace as my main, this green trace is my sub, and now this black trace is the predicted summation based on the current alignment. So let me show you how to play around with this tool a little bit because it's pretty fun. So you want to first just pick some area that seems like it's around the center of the crossover region. And then you can hit level phase at cursor. And this is just cosmetic for your eyes to help you see this phase trace a little bit. And so it's nice for us to be able to see this area, this crossover region between like 55 and 160, where these guys are going to have an effect on each other. And so it just kind of tries to flatten that area out. It just applies the same amount of delay to the same amount of phase shift to both traces so they're a little bit easier to read here. But you don't have to do that. You can undo that and just read this. But I'm going to leave that on for now because I think it's a little bit helpful in this case. And the next thing you can do is either choose between aligning the phase slopes like this, where it uses the group delay, and you can see that now this red trace and this green trace are phase aligned, but not time aligned. Or you can click Align Phase at Cursor, and now you can see in this cursor position, we are actually time aligned at this frequency, and it's supposed to try and do it an octave around this frequency, and so you can see it's sort of the best compromise, right? So how do we find what the right answer is here? Because we have other possible solutions. We could put the cursor in other places. We could invert the polarity and now align phase slopes and now align phase at cursor. And it's pretty clear that this is a better solution than without the polarity inversion. But there are lots of cases where it's not easy or it's not so clear, right? So a nice function that RumiQ Wizard has is this aligned sum. And basically that's just going to make a copy of this black trace right here. So let's try 4 different cases. We'll do align phase slopes, click align sum, that just makes a copy here. And now align phase at cursor, align sum, invert the polarity, do the same thing. And now I have 4 different solutions to pick from. I can close this. Everything gets reset. It didn't change anything. I will hide my original trace. I will zoom in a little bit. So now we're kind of just viewing the crossover region. And first of all, I can see, okay, this brown guy is not going to make the cut. He's not doing very well. He's not helping us out. What can I cut next? Maybe this green guy, not quite enough summation here. Okay. And now I can pick between these 2 guys. They look to me to be about the same. Maybe this purple one is a little bit better. I don't know. The colors are even kind of similar, but this one I can see is a little bit slower. You know, they're not significantly different, but I have to pick one. So I'll get rid of this one. And what I have left then is this guy, number 6. And I see number 6, it gives me the details. It says, hey, B was delayed by negative 4.9 milliseconds, and there was a polarity inversion. How do you get negative delay? Well, in your processing, I recommend that you start with some amount of delay in every output. That way you can subtract delay if you need to. So what I did here is I had 10 milliseconds of delay in every output, and then later on I just removed the excess. So you could, if I had 10 milliseconds of delay here in the sub output, I could now subtract 4.9 milliseconds, but I don't. So in the case that you forgot to do that, then you could just switch it over, and instead of negative 4.9 milliseconds in the sub, you could add 4.9 milliseconds to the main. So it looks like this would have been a slightly better solution than the one I came up with, which we can see over here. And if we look at my result, you can see that I'm not quite getting summation in this area, especially around like 105 up through there. But if we had used this solution here, which was different, then it looks like we could have got a little bit more efficiency out of this alignment. Okay. Probably way more details than you needed, but that kind of stuff interests me. Let's see if there's anything else I was going to say about this calibration process. So here's the final result, and you can see that it didn't actually change much. I basically just took care of this bump here and then tamed down the ends here that I thought were a little bit too hyped. And yeah, I did some listening tests and walked around the audience, and it sounded pretty good to me. Let's take a look at the RF. So RF was very important in this case. There was a potential that the senator would start talking from here. We weren't sure. It turns out that she only spoke in this small area of the stage here. But I had to be ready, right, for her to potentially start talking here at the beginning of the catwalk. I decided to place my antennas here close to front of house, and if I zoom back out, then you can see there's an antenna, and then I had another one over here somewhere. And I felt like, or I could tell this was actually a closer distance than if I had put it over here next to the DL16. So I decided to do that. Let's take a look at Wireless Workbench. So one cool new feature that I hadn't used yet is that instead of just one sweep, you can do continuous sweeps. So you can do multiple measurements and then look at them all on top of each other. And I think those are now organized here. So I could turn these off and on and see, like, here's the measurement that I took on the 29th. Here's the one that I took on the 30th. And I can see if they change from day to day. Okay, so here's the scans. I did my TV channels and those exclusions. What you guys probably know if you've used Wireless Workbench a bunch is that it often misses the television channels. So I guess those get updated from time to time, but depending on whether you're measuring inside or outside, and I guess what time of day it is and what the weather is like, sometimes these won't show up. So you can see that I guess these two are in the database. I can't remember if I did these manually, but you can see that there are more that were not in the database that I had to do manually. So you can right click on these and exclude these. This is a TV channel. These are TV channels. This might be a TV channel. I'm not great at analyzing RF, but I can tell when there's a spike and then a block that it's a detail. So this is probably another one that's just farther away, and this one's farther away. So kind of the workaround that I have found that is quick and seems to get good results is just to grab this exclusion threshold and drag it down until there's basically nothing, no black space left except a little bit, and those should be the highest quality spaces. I hope that's not a bad thing to do. Let me know if you think that that's a problem for some reason. But what I have noticed is if the exclusion threshold is up in its default position and you hit calculate, and it's going to put them around in these different places, and I'm not quite sure how it's deciding where to put those, because yes, this makes sense to me, but this makes sense to me, and this seems like it's kind of on top. Like, why wouldn't it just put them all over here? So I think it's helpful to just drag this down until it basically, you can hit calculate and it will start putting all of the channels into the spaces that look safest. And that's what I did on this day. So I just kind of kept playing around with that. Then assign and deploy, and then I usually reset this back to 85. The only other thing I'll say about the RF is that, after I did the scan and got everything set up, I did a war game test and a walk test. And the auto timeline feature in Wireless Workbench makes the walk test helpful if you're by yourself, like I was. So I just turn on auto timeline. I cover up the antennas with skin so that it, I'm trying to create a problem. I'm trying to create like the worst case scenario. And then I walk up and down the catwalk and see if there are any dropouts, come back and look at the auto timeline and see if there are any problems. So the first time I did have dropouts once I got way back here. And so I adjusted my antenna position, raised them up higher. One had been like turned around by the wind. And I set all the transmitters to high power. I did the walk test again, no dropouts, more solid connection, and I decided to go with that. And then the show went well. Okay, the mix. I don't have a lot to say about the mix. It's pretty simple. It's really just people talking at a podium and some wireless. So 2 podium mics, and then here's the main channel for Senator Harris, and I have a couple of extra RF. I did have a little bit of ringing due to the location of the mic and the sound system. But I found that I could get rid of it pretty easily just by, slowly dialing up this low cut, and it didn't seem to adversely affect the quality too much. So that's why the low cut is so high, as I was sort of dialing it up, trying to get rid of a little bit of feedback. What I'll say about the mix is that the thing I regret most is not putting in some audience mics. And I was told that they weren't necessary, and we were in a hurry, so it was totally fine. But if you look at the recording of the live stream, it's just a little bit sad when it's in between acts because it's all silent. And I'm going to try and find a place. It doesn't really matter. But as you go in between people and it gets muted, like you can hear some music here, but here you go. So it's totally silent. The sign language interpreter has nothing to do. And I just wish I had, an audience mic I could have brought up a little bit in between those spaces. Because there's a lot of energy in the field here that you don't see on screen. There's people singing and chanting and honking and making noise, and that would have been really nice to put into the live stream. If you want to watch this, you can sort of hear the processing I was doing on the vocal mic, but you can't hear anything in between. Oh, I have this whole section over here for the mariachi band, but I don't think I did really any processing on them. They just walked up and started playing, so I just put everything flat and then just did a mix on the faders really quick. I do like to use these combinators. I don't love them. They're not super helpful, but they're a little bit helpful, so I usually leave them in, and then, while the person is talking, I'll start to bring down the threshold a little bit until I get a little bit of compression. And so on the channels themselves, I usually use the dynamics. I leave the threshold way high. It's just there for a few peaks, and then where I can, I really try to do more of the dynamics with that combinator. And I think that's it for the mix. So that's the mix. I talked about the recording. I wish I had some audience mics. And that's pretty much it. So let me know what you thought about this. Let me know what questions you have about this design or how I calibrated the sound system. Let me know if you have any suggestions for me. I'm always trying to improve my understanding about these systems and how they work. So let me know in the comments below this video. Thanks. Sound design. Yeah.